Hello dear students, welcome to the new video of Haloalkane and Haloarene. In today's video, I'll teach you the physical properties of haloalkane. So when it comes to physical properties, we mostly study like solubility, boiling point, melting point, density under physical properties of haloalkane. So we'll start with boiling point. So in the boiling point, we'll take different set of compounds and we'll compare their boiling point. So the first set of compounds I'm going to take are CH3F, CH3Cl, CH3Br, and CH3I. Now, if you keep the alkyl group same, the boiling point increases with the increase in the size of halogen atom. Now when we look at the group 17 elements, it's fluorine, chlorine, bromine, iodine. And as we go down the group, the size of the halogen atom increases. So for a given alkyl group, the boiling point increases from fluorine to iodine. So the order of the boiling point will be CH3F less than CH3Cl, less than CH3Br, less than CH3I. Next set of compounds. So you can see here, the halogen atom is same, but the length of the chain increases. So if for the same halogen atom, the boiling point increases with the increase in the length of the chain, the hydrocarbon chain. So the order of the boiling point here, CH3Cl less than CH3CH2Cl less than CH3CH2CH2Cl. Next, let us see for isomeric haloalkane. Now, if you look at these compounds, you'll find the number of carbon atom, hydrogen atom, and halogen atom is same. So we can say the size of this compound is same. Now, how will you compare the boiling point? Now, the boiling point for such compounds is compared based on the nature of the chain. So, if we have branching, the boiling point decreases with increase in branching. So you can see here, for the first compound, you have all the carbons in a straight line. That means it's a straight chain. In the second compound, you have one alkyl substituent, that is methyl group. In the third compound, you have two substituents. So if you compare these three compounds, you'll find the branching is maximum in the third compound and is minimum here. There is no branching here, it's a straight chain. So the order of the boiling point, this will be more than this. That means this is 1 chlorobutane. 1 chlorobutane boiling point will be more than 2-methyl propyl chloride, will be more than the third compound. So the order is this. 1 chlorobutane more than 1 chloro 2-methyl propane is more than 2 chloro 2-methyl propane. Next, Now, when we look at these compounds, you can see the number of carbon atom is same, but the number of halogen atom increases. So, for same number of carbon atom, the boiling point increases with the increase in number of halogen atom. So, this compound having one chlorine atom will have a lower boiling point than this, because this compound has got two chlorine atoms. This will be less than CHCl3, will be less than CCl4. Now from these topics, you'll mostly get questions like you'll be given some compounds and you'll be asked to arrange them in increasing order of their boiling point or decreasing order of their boiling point. Next, we'll study the solubility of haloalkane. So when it comes to solubility, we study the solubility of haloalkane in water. Now if we take an example of haloalkane like CH3Cl. Now Cl is more electronegative than carbon. So this compound is a polar compound. Even though it's polar, it's still insoluble in water. Now why is it insoluble in water? It's because a water molecule, it forms a strong hydrogen bond with another water molecule. So haloalkane, the CH bond, though it's polar, but it's not strong enough to break the hydrogen-oxygen bond in water molecule. That's the reason haloalkane, though it's polar, but insoluble in water. Next, we'll study the chemical properties of haloalkane. So on the chemical properties, we'll first study nucleophilic substitution reaction. Now, in nucleophilic substitution reaction, one nucleophile will be replaced by another nucleophile. Let us try to understand with the help of example. Let us take this compound, chloromethane. Let it react with KOH, aqueous solution. Now you have to be very careful. Potassium hydroxide in aqueous and potassium hydroxide in alcoholic solution will not give the same product. When it comes to aqueous solution of potassium hydroxide, it will give nucleophilic substitution reaction. But alcoholic solution of potassium hydroxide will give elimination reaction. So you have to be very careful here. Now, if chloromethane reacts with potassium hydroxide in aqueous medium, Cl is replaced by OH. That means the nucleophile Cl is replaced by the nucleophile OH. So you will get this compound CH3OH plus KCl. What is the name of this compound? Methanol. Let us take one more example. So CH3 CH2Cl plus KOH, aqueous medium. So again Cl will be replaced by OH. So you get CH3 CH2OH plus KCl. So chloroethane will give ethanol. So in general, we can write this reaction RH, where R can be any alkyl group, X can be a halogen atom, X can be F, Cl, Br, I. And it will react with KOH in aqueous medium. So X That means the reaction condition for RCl will not be same with RF. Let us take another example of nucleophilic substitution reaction. Let us study the general reaction first. Rx plus KCl. So when Rx reacts with KCl, you will get RCl plus Kx. Example, CH3Cl, if it reacts with KCl, you will get CH3Cl plus KCl. Whereas if Rx reacts with AgCl, you will get RNC plus AgX. Example, CH3Cl plus AgCl will give CH3NC plus AgCl. Now, this compound is known as alkyl cyanide, whereas this compound is known as alkyl isocyanide. Now you can see in the first case, the alkyl group forms bond with the carbon atom, whereas in the second case, when we take AgCl, the alkyl group will form bond with nitrogen atom. Let us see the reason for it. If you take KCl, KCl is ionic in nature. So if it is ionic, it will give ions, that is K positive and Cl negative. Now here, the negative charge is on carbon atom. So if it is ionic and if the negative charge is on carbon atom, carbon will be a better donor. So in the first case, carbon forms bond with the alkyl group. Whereas in the second case, when we take AgCl, AgCl is covalent in nature. So it will give AgCl. And if there is no charge, nitrogen is a better donor. So that's why in the second case, the bond is formed by nitrogen atom. So you can see example like if you take CH3Cl, chloromethane reacts with potassium cyanide, you will get methyl cyanide and potassium chloride. Whereas if you take chloromethane and silver cyanide, you will get methyl isocyanide and silver chloride. Now, let us see the next example of nucleophilic substitution reaction. Rx plus KNO2 will give RONO plus KX. Example, CH3Cl plus KNO2 will give CH3ONO plus KCl. Alright. In place of KNO2, if you take AgNO2, you will get RNO2 plus KX, AgX. Example, if you take CH3Cl plus AgNO2, you will get CH3NO2 plus AgCl. Now, the same concept applies here. If you take potassium nitride, KNO2, you'll get alkyl isonitride. But if you take silver nitride, you'll get alkyl nitride. Now, same concept applies here. If you take KNO2, KNO2 is ionic in nature. So if it is ionic, we will give ions and there will be negative charge on oxygen atom. That's the reason the oxygen atom will form bond with alkyl group. But if you take AgNO2, the AgNO2 is covalent in nature. So in this case, nitrogen will be a better donor than oxygen. So nitrogen will form bond with alkyl group. Let us see the next nucleophilic substitution reaction. Rx plus NH3. Now, alkyl halide, NH3 is ammonia. So when alkyl halide reacts with ammonia, forms amine and halogen acid. Example, CH3Cl plus NH3 will give CH3NH2 plus HCl. Now when chloromethane reacts with ammonia, it will form methylamine and hydrogen chloride. So what is the nucleophile here? The nucleophile here is NH2. So NH2 will replace Cl. So when it comes to nucleophilic substitution reaction, there are two very important mechanisms which we need to study. So there are two types of mechanism. Now before going into the mechanism, what is mechanism? Mechanism is basically the detailed study of the reaction. In mechanism, we study every step in detail and we try to understand how the reaction is taking place. So when it comes to nucleophilic substitution reaction, there are two very important types of mechanism. That is SN1 and SN2. SN1 is substitution nucleophilic unimolecular, whereas SN2 is substitution nucleophilic bimolecular. So we are going to study these two mechanisms in detail. We also will study how the reactivity depends on different types of alkyl halide. So we'll study the mechanism in the next video. Thank you.